Hi, dear students. Today we'll have first lecture at linear programming by Dr. Sarah Sayed. First of all, we must determine in this part requirements of a linear programming program, then formulating linear programming problems. Also, in this part, you must determine or study graphical solution to a linear programming program through graphical representation of constraints, isoprofit line solution method, corner point solution method. The main learning objectives for linear programming course: number one, formulate linear programming models including an objective function and constraints. Two, graphically solve an linear programming problem with the ISO profit line method. 3. Graphically solve an linear programming problem with the corner point method. 4. Construct and solve a minimization problem, also a profit maximization problem, as the same. 5. Formulate production mix, diet and labor scheduling problems. We can define linear programming as a quantitative technique or operational research technique which is designed to solve a problem. Linear programming is a mathematical technique to help plan and make decisions relative to the trade-offs necessary to allocate resources. Also, linear programming will find the minimum or maximum value of the objective. Linear programming guarantees the optimal solution to the model formulated. Here, some examples for linear programming application. Number one, linear programming can be used to schedule school buses in order to minimize total distance traveled. Also can be used for police units to high crime areas in order to minimize response time to emergency calls. Also can be used at scheduling tellers at banks so that needs are met during each hour of the day while minimizing the total cost of labor. We can use linear programming also in selecting the product mix in a factory to make best use of machines and labor hours available while maximizing the firm's profit. And in this part will be the main working example according to linear programming during our course. The product mix is the main one. Number 5, linear programming can be used to pick blends of raw materials in factories to produce finished combinations for products at minimum costs. Also, it can be used to determine the distribution system that will minimize total shipping costs. Finally, linear programming can be used to develop a production schedule that will satisfy future demands for a firm's product and at the same time minimize total production and inventory costs. Here, you must determine the requirements in order to solve linear programming problem. Number one, linear programming problems are seek to minimize or maximize some quantities expressed as an objective function. So objective function express or maintained in order to two ways maximize the profits or costs to maximize profits or minimize costs. Two, the presence of restrictions or constraints limits the degree to which we can pursue our objective. There must be alternative courses of actions to choose from, and this can be expressed at the corner points that we will study later. Objective and constraints in linear programming problems must be expressed in terms of linear equations or inequalities. Here we'll have a real problem about linear programming for AB company at electronics. AB company for electronics. This company has two products. First, A is a portable music player product. Second is AB Blueberry is an internet connected color telephone product. Our work is to determine the mix of products that will produce the maximum profit. The mix of each product, the mix of each product that will give you the maximum profit. Here some information about Xpot and Blueberry. We will have a sample for Xpots like X1, and Blueberry product will have a sample as X2. Here 4, 3, 2, 1, they are the hours required to produce one unit, which means in order to produce 1 unit of Xpots, you will have 4 hours. Again, in order to produce 1 unit of Xpods or X1 product, you need 4 hours. In order to assemble the Xpods product or X1, you need 2 working hours. 2 working hours. While at Blueberry's product or X2, you need 3 working hours to produce. While at assembly working hour, you need 1 hour only for X2 or Blueberry's product. The constraints here will be found as 240 hours and 100 hours, which means that in order to produce X1 and X2, you must be less than or equal to 240 hours. You cannot be more than 240 hours. For example, you can say to produce X1 and X2, you need 241 hours. Will not be permitted at all. So, for producing X1 and X2 products, you need 240 hours. The same at assembly working hours. You need not more than 100 working hours for X1 and X2. You'll find $7 and $5. Those are the objective function units will be used at the objective function. But 240 and 100, they are the constraints. Again, 240 and 100, they are the constraints. While the profit per unit for X1 is $7 and profit per unit for X2 is $5. Here is the objective function, which is maximize profit is $7 at X1 plus $5 at X2. We have three types to make our constraint: upper limits, lower limits, and equalities. Upper limits going to the maximum or maximize profit, which will have the sign or symbol for less than or equal, while the lower limits is used for minimize costs, which is greater than or equal. Equalities, they are the same. There is no profit or there is no cost, which will not be used at all. We will concern on the maximize profit or minimize costs. As we said before, returning to your table, we found that 4x1, which is 4 working hours to produce x1 unit, plus 3 working hours to produce x2 unit. Both x1 and x2 cannot exceed 240, which is the constraint. And we have the symbol of less than or equal going to maximize profit. The second constraint, you have 2 working hours to assembly x1 and only 1 working hour to assembly product x2. Both x1 and x2 cannot exceed 100 hours of assembly time. And also we put the constraint that less than or equal for maximize profit. Thank you for your attention.